All right. In the world of 3D graphics, there's a new technology that is making some serious waves. It's called Gaussian splatting, and let me tell you, it's not just a small improvement. It could totally change how we create and experience digital worlds.
I mean, think about it. For decades, this has been the ultimate goal, right? The holy grail of 3D, making something that looks perfectly real and runs perfectly smooth. Imagine capturing a real place and then just walking through it on your computer with every little reflection and texture there and zero lag. Well, that future, it might be a lot closer than you think.
So, what is this stuff? At its core, Gaussian splatting is a totally different way of thinking about a 3D scene. You know how we usually build things with flat polygons? Forget that. This uses millions of tiny, colored, kind of transparent blobs called splats. The best way to picture it is like a super dense cloud of colored dust that comes together to form an image with just breathtaking detail.
And no, this isn't just another small step forward. We are talking about a genuine leap, a new way to capture and render our world that just might solve a huge trade-off that's been bugging 3D artists for years. And this gets right to the heart of it. In 3D graphics, you've always had to pick your poison. Either you get these gorgeous, lifelike visuals that take forever to render, or you get a fast, interactive experience that looks, a bit gamey. Gaussian splatting is all about giving you both. You get the photorealism, and you get it at fully interactive frame rates. Now, to really get why this is such a game changer, we need to compare it to the old champion, the technique that's been running the 3D world for decades, the polygonal mesh. So you can see right away it's a completely different philosophy. Meshes are all about connecting dots to make solid surfaces. That works great for clean, man-made stuff. But when you try to capture the real world, things get messy. You get holes, weird geometry, it's a pain. Gaussian splatting just sidesteps that whole problem. It's not building a solid skin, it's filling a volume with these splats. And that makes it unbelievably good at capturing all the fuzzy, complicated stuff like leaves on a tree, or hair, or even glass. This table really breaks it down. Look, for character animation, meshes are still king. It's easy to bend and stretch their solid surfaces. Splatting isn't really built for that, yet. But for detail capture, it's no contest. All those fine details that meshes miss, splats capture beautifully. The only catch right now is engine support. You can't just drag and drop a splat file into any old game engine and expect it to work. But that's changing fast. And this quote just nails it. A mesh is like a statue. It's rigid, it's solid, it has defined edges. A splat scene is more like a cloud. It's fluid, it's made of countless tiny points that create the illusion of a solid object, but with way more nuance. It's just a whole new way to think about what a 3D object even is. But hey, meshes aren't the only other tech out there. A little while ago, a technique called neural radiance fields, or NeRFs, blew everyone away with photorealism. NeRFs use AI to generate these incredible images, but Gaussian splatting has one massive advantage over them. Okay, the key difference here is this idea of implicit versus explicit. A NeRF is implicit. It's a deep, complex neural network that has to think about what a scene looks like from every angle. So to see anything, you have to ask the AI, and that's slow. Gaussian splatting is explicit. The scene is literally just a big list of splats with their properties. Your GPU doesn't have to think, it just has to draw them. It uses rasterization, the exact same super fast process that powers pretty much every video game you've ever played. And just how fast is fast? We're talking real-time performance, 30 frames per second or even more, running on regular consumer GPUs. This is the speed that NeRFs have always dreamed of, and it's what makes splatting so practical for games, VR, and all sorts of interactive stuff. This quote just sums it up perfectly. It's like it takes all that amazing visual quality that NeRFs pioneered and puts it on a rocket ship. You get the photorealism without having to sit around waiting for it to render. Okay, so we know what it is, we know why it's so fast, but how do you actually make one of these things? So the most common way to do it starts with something called photogrammetry. It's actually pretty straightforward. You just take a ton of pictures or a video of something from all different angles. Then some clever software analyzes those images and figures out a basic 3D point cloud. Then comes the magic. The algorithm takes that point cloud and turns it into millions of these Gaussian splats, tweaking their size, shape, and color until what it renders looks exactly like your original photos. So yeah, you can use a camera to capture the real world. That's incredibly powerful. But that's only half the story. What if you didn't need a camera at all? There's a new approach that is frankly kind of mind-blowing. Instead of capturing a scene, what if you could just generate one with AI? New models like World Labs Marble can take a simple text prompt, something like a quiet forest clearing at sunrise, and create an entire 3D world directly as a Gaussian splat scene. Think about that for a second. The AI isn't just making a flat image, it is building a fully explorable, photorealistic 3D space from nothing but a few words. And this part is absolutely critical. Gaussian splatting isn't some cool idea stuck in a research paper anymore. A whole ecosystem of software and tools is exploding around it, which is making this tech more and more accessible every single day. This means creators actually have options now. You can dive into powerful open source tools like NeRF Studio. You can use pro-level software like the Valinga suite for virtual production. Heck, even the established giants of photogrammetry like Pix4D are getting on board and adding Gaussian splatting as an export option. The tools are here. And it's not just about making them, it's about using them. We're already seeing plugins that bring splat rendering straight into game engines like Unreal. And for the web, there are open source libraries like Spark that let you display these amazing scenes right in a browser. This is that last, crucial piece of the puzzle. The tech is moving into the places where creators actually build things. So let's wrap this all up. What do you really need to remember? First, this tech finally delivers on that old promise: photorealism and real-time speed. Second, it's an incredible new way to capture the messy, complicated beauty of the real world. Third, because it's explicit, it's just way, way faster than previous methods like NeRFs. And finally, the ecosystem of tools is absolutely blowing up, which proves this thing is here to stay. Which leaves us with a really fascinating question to chew on. For decades, we've carefully built our digital worlds, one polygon at a time. But with technology that can capture or even generate reality with this level of quality and this easily, you have to wonder, will the virtual worlds of the future be meticulously constructed by artists, or will they simply be a perfect copy of our own?